Well, it's great to be here. I always like coming to the IIIS facility. A number of years ago, I was a science fellow sponsored by the American Physical Society under the IIIS umbrella. And your chair, Marty Sokolowski, was an IEEE IIIS fellow, and I'm pleased to say in my office just a few years back. So when Marty invited me to come, I immediately said, yes, I'll find a way to do it. And I'm really delighted to see what a success this program is. I'm impressed by the other speakers. I wish I could be here for the whole program because there are some lessons that we need to carry forward in Congress. You know, our country's leadership role in innovation is being questioned, really for the first time in 150 years. We always thought that the sky was the limit. And one thing I would say, I noticed that Rob Atkinson, for example, is on your program. I was with him earlier this morning. We were talking about the new book concerning Bell Labs. And one of the points that I like to make is that we shouldn't fall into despair and hand-wringing. We still have excellent education. We are the largest manufacturer in the world. We still have quite a lot of innovation, but we are not the unquestioned leader, and many of the first and second derivatives are of the wrong sign. So it is, there's a lot of work we need to do. The rankings of competitiveness are problematic. It's hard to know what the metrics should be. Rob Atkinson, among others, deals with those things. But we do know that in the last decade, according to a number of different measures, other countries and entities with whom we would compare ourselves and maybe want to compete economically and actually in some cases perhaps even militarily, are moving ahead faster than we are. A lot of global firms are building new R&D facilities overseas in China and India. The number of patents coming from other countries, well, for example, China has gone from 15th place to 5th place. These statistics are troubling, and they illustrate not that we wish China ill, it's just that others are moving ahead in ways that it's not clear that we are. So what do we do? Well, when the America Competes Reauthorization Act was passed a couple of years ago, I inserted language asking the Department of Commerce to prepare a report on economic competitiveness and our capacity for innovation. That report is out. I wouldn't say it's earth-shaking one way or another, but it's worth noting that the report stressed 3 areas where we need to make investments, and I want to emphasize that word, investments. The 3 areas are research, education, and infrastructure. They mean infrastructure in at least a couple of senses of the word. So it's not only building the lab facilities and the hardware, but also the research and education infrastructure, the virtual infrastructure that is necessary. In our discussion earlier this morning on Bell Labs, which was really a breathtaking model of innovation that may not be, it's possible, could not be duplicated today. It was successful, they were successful for a variety of reasons. The proximity of a lot of different kinds of people who could do materials and optics and electronics, all under the same roof. They'd meet in the cafeteria or the hallway, but also they had on hand the best glass blowers in the country and the best circuit designers in the country, and there was truly a critical mass that was really very productive. There was also the willingness to dream. I mean, yes, they were interested in getting a phone call from West Street or Murray Hill to San Francisco. They were trying to develop a communications industry. But they also pioneered the field of radio astronomy. They did research on detection of gravity waves. Not in our lifetime will we be communicating by gravity waves. This was not something that Bell Labs had to do, but they, in the process, developed, perfected some of their low noise amplifiers. It was a willingness to go into new areas, a willingness to take risks, a willingness to fail, an organization for asking questions that paid off big. It paid off for that industry. It paid off even more for the country at large. And I would say the same thing applies in education. What we need is diversity and such a widespread community that there will be many places with a critical mass of teachers to support other teachers, a critical mass of industry and other organizations to support those teachers, a critical mass of industry to inspire and hire the students. It won't work, I believe, if we say this will all be done in a dispersed manner. You know, I'm pleased to see the session on output measures and indicators. For research and for education, we need to pay a lot more attention to these measurements. Not because we will stop those activities that don't, in the short term, lead to an improved bottom line. Again, if Bell Labs was interested only in the short-term bottom line, they never would have developed the long-distance telephony, the radio dishes, the gravity wave detectors that indirectly really enriched their process. I've been involved in STEM education, well, first as a consumer, and then as a practitioner, and now as a policymaker for many decades. And it's common to point to the National Defense Education Act as the start of modern science education. This was 1958 in response to the Sputnik Soviet satellite, when in panic that not only were we losing ground competitively, but we were losing the high ground militarily, and it was going to be curtains for the free world, that Congress passed this important educational legislation that was based on the assertion that we would produce a generation of scientists and engineers the likes of which the world has never seen. We did, and generations after that even. I'm a product of that Sputnik revolution, and some in this room probably are. But the problem was that we essentially said to 90% of Americans that science is not for you. If you're not going to be a professional scientist, never mind. And so we end up with a Congress where there are, well, there's one research-based physicist, there's a research-based chemist, there are a few other people, depending on how you define science, who might be categorized as scientists, and then about 420 of them who say, oh, science is not for me, I can't touch that. Nope. Including all those members of Congress who are not at all reluctant to talk about things in which they're not trained, except science. Now, yes, you laugh, but you should darn well hope that members of Congress are able to deal with things in which they aren't trained. This is a complicated country. We need good policy in every conceivable area, and members of Congress should be able to think, speak, and act intelligently in any area, international affairs, economics, transportation, whether they've had training in the area or not. But when it comes to science, they say, no, that's not for me. I can't do science. Where are the scientists? And they look around in the room, and there are a couple of us, but that's not good enough. AAAS, a number of years ago, established, at the time they established Project 2061. Do I have that right? Somebody here? No? Okay, yes. Produced a book called Science for All Americans, with an emphasis on how we get every student to a position where she or he can think and act intelligently on questions of science, where each student can behave like a scientist, act like a scientist, or in other words, ask questions so that they can be answered empirically and verifiably. The shortcomings of the Sputnik revolution in science and math education haunt us today. We have focused on producing that generation of scientists and engineers that would carry us forward, forgetting that what carries us forward as a country is the great mass of Americans. Yes, we have had great scientists and engineers and great innovators and great business tycoons, but they have all stood on the shoulders of others. There's a lot of talk about whether our economy can move forward with the kind of divisions that we have between the rich and the poor. I think actually those divisions are hampering our forward progress. But it certainly is true in science. As I said, Bell Labs didn't go forward just because of a Shockley and a Bardeen or a few great PhD scientists. They also had the best glass blowers in America and the best circuit designers. And it means policymakers value the fruits of research and science, but don't have a clue about how the enterprise works and what needs to be done to foster it. What we need is science for all Americans. Not that everybody hopes to wear a lab coat someday, but that everyone will understand what it takes to support the enterprise. For most of America's history, we actually had that. I would argue that all Americans thought like scientists. Every farmer, every shopkeeper, every factory worker really embraced learning, embraced hypothesizing, embraced empirical thinking and experimenting. And we seem to have lost that skill. So it's not enough to have inquiry-based science in the first 4 grades. We have to find some way to carry that into adulthood. If we're going to remain competitive, I think we have to provide STEM education for all Americans, not just the 10 or 15% that we have looked to for all these years, in recent years, and go back to the idea of a country where, you know, in every small town in the Midwest, one of the most exalted people in town would be the person who had a patent. This was true in farming communities all over America. The person who went off to get a PhD was really looked up to in a way that everyone said, well, I can understand what this person is doing. I care about what this person is doing, and I want my kids to care about what this person is doing. Rather than to say, yeah, he's a scientist and we're farmers. That's not the American way. The way to say that there are indeed 2 cultures. So as you talk about the mechanisms of STEM education and the training and professional development of the teachers and the equipping and designing of the labs, remember that you're also talking about the social experiment here of providing science for all Americans. Thanks for holding this conference. I'm delighted to be here with you, and I wish I could stay for the whole program. Thanks.
Okay, the Congressman has got time for some questions. Anybody? Ed, you want to identify yourself?
I'm Ed Perkins. I'm a IEEE volunteer from Oregon, and we were looking at the online education that's coming in. One thing that dawned, I mean, you look at people who are don't want to spend money and all that kind of stuff, and it dawned on me that maybe what we're seeing is the labor-intensive modes of doing things. People are saying they don't want to pay for anymore. They can't afford to pay for anymore. And that doesn't necessarily fit everybody's learning style, but what do you think about that? Are we seeing a big transformation here where we're going to have to go to a completely new ways of training people?
Well, I think we will go to lots of new technologies, but not new humans and new brains. We still learn in ways, and another thing that has been lost is we can learn a lot about how we learn, and we mustn't forget that. There will be improvements in that, but a lot of commonality. And we'll be able to do, obviously, some of the education with, wonderful lab equipment. And in other situations where the lab equipment isn't available, you'll do it through computer simulation. And in other places, you'll have to do it with improvised experimental technique. But all of these will work if you don't lose sight of the fact that what you're trying to provide, and at least this is in the elementary and secondary level, is not a training and expertise and a facility with particular experimental equipment, as it is so much to sharpen the ability to ask questions so that they can be answered empirically and verifiably. I mean, that's science. To be able to ask questions so that they can be answered using data and observations, and that you can communicate your answer to the question in a way that your work can be checked. And scientists call that publication. And every child can do that. And if everyone came out of the schools with a well-honed ability to do those things, to ask questions so that they can be answered empirically and verifiably, I think we would have a re-energized, innovative economy and society.
Please identify yourself.
I'm Rose McConnell from a university, Western Illinois University, and I'm an administrator as well as a chemist. And my question is, in the area of science literacy and promoting science literacy to the population, do you see any future support for that on the government level? Anywhere comparable at all to that of research and development?
A great question, because that is just as needed as support for big science and so forth. I'm concerned. I'm concerned about support for science in general. Federal support for science has fallen by about half over the last 4 decades. That's kind of overall. And the parts of the National Science Foundation, for example, and Department of Energy and NASA and so forth, that deal with outreach, public science, museums, and some of these other science literacy programs are not healthy, I guess, is the way I would put it. Still, in a subset of our population, we're doing really quite well with science literacy. I mean, you can find kids in any school who can talk to you quite intelligently and maybe even showing off a little bit how much they know about how the world works and the science literacy. But when I talk about science for all Americans, really that's what I'm talking about. It sometimes goes by the name science literacy, although I don't want to dwell on memorizing Latinate terms or formulas, but rather an appreciation of how things work and how you can validate your thinking by grounding it in data and holding it out for public criticism. One more, maybe? Yeah, thanks.
Ralph.
Russ, and
Identify.
Ralph Windrum. I recruit for Columbia University Engineering School students, and that's the drive of this question. In doing so, I have found that the number of qualified science and math teachers in the high schools is pitifully low. And states such as New Jersey, as you know, have high-tech high school, which has the good point of bringing together a core of key teachers, but it has also drained the very best students from many of our high schools in the New Jersey area to the high-tech high school and others like it. My question is, isn't there some federal policy initiative that could really revitalize the science, math, technology teaching staff across the country, which is absolutely fundamentally needed at this point?
The answer is yes, and actually I've done something in the area. It's not enough yet, but for example, a few years ago, I wrote the legislation, now the law, that provides upfront grant money for students who go to college preparing to teach science, math, and foreign languages. And they would get $4,000 a year for 4 years, up to $16,000 up front. Now, that's not full tuition by any means. There are some strings attached. I mean, you have to teach for 5 years afterwards, which is actually not a string, but that's the whole point of the program. And there are some other things of the sort. But if we wait to address this problem saying that there aren't enough trained teachers, we'll run into problems. Now, with regard to High-Tech High, sure, it has 100 really good kids. They're taken more or less at random. Obviously, there's a lot of self-selection. These are students who want to go to High-Tech High. But it's only 100 in Monmouth County, for example. So there are thousands yet in Monmouth County who are of high caliber. So it's not as if it drains the schools of all the expertise. Now, High-Tech High does have more teachers with PhDs or advanced degrees than most of the other schools in Monmouth County. And so you can either lament that and wring your hands, or you can say, we're going to provide professional development for those teachers who are in the other schools. We're not going to give them PhDs. That just isn't going to happen. But we can give them a good professional development program. And that is what's missing in much of education in America. Any business you go into, any corporation, they'll spend 5, 10, sometimes 20% of their personnel budget on training. Now, sometimes they'll say, well, it's because we need it, we can't get the people we need, whatever. But they spend a lot of money on training. You ask your school board, how much do they spend on training? And that maybe you should define for them what you mean by training, professional development. And it's going to be a couple of percent of their salary budget. So clearly, we can do a much better job. It shouldn't be just 1 or 2 in-service days during a semester. It has to be something that's worked into the daily and weekly program for peer development and so forth, to get real professional development for the teachers we have, rather than wringing our hands about the teachers we don't have. Now, meanwhile, of course, we want to bring more trained scientists and engineers into the teaching profession. But let's not wait for that. Let's make the investment in professional development that we can make right now. And each school board should be doing that. Thanks very much.
Okay, thank you.
Thanks. Hey, thank you, Marty.